Hello and welcome to our channel again. So here I am Suraj with a new video of mine on the Fourier transform, that what exactly this Fourier transform is. In the previous video I have discussed about the Fourier series of any type of the particular functions, and the Fourier transform is some sorts of advanced version, and the word transform means that how can we transfer it some from another dependent quantity to some another dependent quantity. Okay, so basically we are going to do this particular Fourier transform, and also there is a demanding question on the Fourier transform by the atomic primer, which we will deal in the next video. So now let's start our video on the Fourier transform. So I have written here that this is a particular expression for the Fourier series of any function which is dependent upon time. It means we have write the series of function which is dependent upon time. So Fourier transform, what it do, that it just transform this particular function to the another functions which is dependent upon the frequency. It means, what do you mean by Fourier transform? I will write it f of t is that it will just convert this particular function from time dependent to the frequency dependent. That's why Fourier transform is known as going from the time domain to the frequency domain. And the frequency can be anything. Omega represents the angular frequency. Maybe it should be the not an angular frequency as the normal linear frequency. So the Fourier transform will exactly the transformation of this particular time dependent function as written in the Fourier series to the frequency dependent function f omega, or f of the any type of the linear frequencies. So how we can do this particular Fourier transform, we are going to discuss in this video. So there is a particular formula for the doing Fourier transform, which I will write here, that it is written as f of omega. Okay, it means now this particular functions dependent upon omega, not on the time. So how we can do this? Because analyzing the frequency is much more simple than analyzing the particular time. Okay, so that's why we will transform this from time to the frequency, maybe angular and normal frequency. So it can be written as 1 over root under 2 pi integration from negative infinity to the positive infinity of f of t function, which is a time dependent function, which is dependent on time, into the e I omega t, okay, and into, or you can say that with respect to the dt. So this is the basically the method for transforming our time dependent Fourier series into the series which is now dependent upon the frequency, not on the time period. So this is a typical formula. So what's this typical formula? Now this formula derives. So the derivation of this particular formula may be in the next video, but now we are going to analyze that what exactly these terms mean. So suppose that there is a say there is a particular, I'm going to draw a graph so that you can understand in a better way, that suppose that there is a graph of time and the particular, just like the sine waves, okay? So just like the sines and cosines wave frequencies, maybe we deal with in the theta degree, okay? So maybe there is a function which is dependent upon time and its particular values dependent upon time. So what the Fourier transform will do, is suppose it is dependent upon time, it may be complex, okay? It may be complex, maybe sine, cosine. So maybe our next intuition is to just develop the, not the time, but the omega, or you can say that angular frequency dependent particular Fourier series. So let's run another graph here, and now we will represent the omega for our particular Fourier series. And it is very easy because we are dealing with the omega frequencies, which is quite useful in almost every branch of the physics and mathematics, because time is not well defined in, maybe let's say in the quantum mechanics, when you have to do the Fourier transform of the free particle, we will generally do the Fourier transform on the wave number known as k, okay? So that's why Fourier transform, it's very useful to analyze our any type of the function. So this is my small video on discussing about what is Fourier transform and giving you the brief introduction about the Fourier transform. Maybe the derivation of this particular formula that I have written here, maybe in the next video I will do this, and also some questions on demanding questions on the Fourier transform and Dirac-Coombe function. So thank you for watching my video.